Question 8 is saying the diagram shows the circle with equation x squared plus y squared minus 14x plus 8y plus 36 equals 0, and the line y equals minus 2. The line intersects the circle at the points A and B, and the center of the circle is C. Then part A says find the coordinates of A, B, and C. Alright. So if A and B share the same y coordinate, we can just plug it in to the equation of the circle and get the two x values for each. Alright. So plugging minus 2 for y, we'll get x squared plus minus 2 squared minus 14x plus 8, then minus 2 for y plus 36 equals to 0. Right? Simplifying this, we get x squared plus 4 minus 14x minus 16 plus 36 equals 0. Right, and simplifying this further, we get x squared minus 14x plus 24 equals 0, like that. Right, and for us to get the 2x values, we're going to use the quadratic formula. So x equals to 14 plus or minus 14 squared minus 4a is 1, c is 24 over 2, like to be. First one is 12 and the second one is 2. Right, so looking at our coordinates, A is 2 minus 2 and B is 12 minus 2, like that. Right, and since we were looking for the coordinates of A, B, and C, we are only left with C. For C now, we're going to be using this expanded form of the equation of a circle. Since we know that the coefficient of x is 2g and the coefficient of y is 2f, we're going to come down here and say 2g is equals to minus 14. Therefore, g is minus 7. Right, and 2f is equal to 8, and f is equal to 4. Right, now with these, we know the center is minus g minus f. So the coordinates for C, which is our center, will be minus g, which is minus 7, which is 7, and minus f, which is minus 4. Right, and these will be our coordinates for A, B, and C. Then part B says find the angle ACB in radians. Give your answer correct to 3 significant figures. Angle AB, so A was what? 2 minus 2, and this was 12 minus 2. C was 7 minus 4. Like this. And the question is asking us to calculate to find the angle ACB. So the angle is at C, so it's angle ACB, which is this angle right here. Right, and how many marks? 2 marks. So for 2 marks, then we're going to introduce another horizontal line. Yeah, like this. Alright. And now with this horizontal line, we are going to say this part is equal to this part. Right? Because we know that CB is a radius and CA is also a radius, so those two are equal. And with that in mind, you also know that this angle is equal to this angle, right? And if we look at this diagram, this line is meant to be parallel to this. So this, if we call this angle theta, this will also be theta, right? And this will be theta, and this will also be theta, right? And we can get this theta if we introduce a vertical line like this, because you know this point is 7 minus 2, right? So this distance right here, this one, will be from minus 4 to minus 2, which is 2 units, and this one will be from 7 to 12. 7 to 12, that's 5, right? So we can find theta there using this is opposite and this is adjacent, so it will be tan theta equals 2 over 5. So theta will be the tan inverse of 2 over 5, which will give us, no, we'll get a value for this, but we know that this is theta and this is also theta, so we can multiply this by 2 so that we get the value for these two angles, and we subtract from 180 because it's on a straight line, right? We have something like this in the straight line, so if we can get these two, we can subtract from 180 to get this line, this angle, I mean. So multiplying that by 2 tan inverse of 2 over 5, right? And that will give us 0.7610, like that, right, in radians. And now to find the angle that we've been asked to find, we now say pi, which is a 180 minus the answer that we got for the two angles, and this will give us 2.38 radians, right? So that's 2.38 radians for that angle, right? Or for the second method, we can say, let me just rub this out. We can say it's ACB, like this. So if we introduce a horizontal line like this, to get an angle between a horizontal line and a slanting line, we just say tan inverse of the gradient of this line, the slanting line, right? So for the gradient of CB, we can get it by saying minus 4 plus 2 over 7 minus 12, and that will be minus 2 over minus 5. That will be 2 over 5, right? The gradient of CB. So to get this angle between this horizontal line and CB is just the tan inverse of 2 over 5, right? But we know that this angle will be equal to this, so you multiply this by 2, then you just say 180 minus that to get this angle, right? And you get it to be 2.38 as well. Number 11, part C, is saying the chord AB divides the circle into two segments and find the area of the largest segment, right? The chord AB divides the circle into two segments, find the area of the larger segment. And for that, we're going to use our diagram. We're told AB divides the circle into two segments. So this is segment A, and this will be segment B. And the question says find the area of the larger segment, which is segment B, right? So we want the area of segment B. But if we look at the previous questions, for part B, we were asked to find the angle ACB, is this angle, right? And we got it to be 2.38, like that. So to get this area, we can say area of this sector plus area of this triangle right here. And for area of this sector, we need this angle, which we can get by saying 360, which is 2 pi 360 minus 2.38, right? Area of that triangle. And for that, we said we're going to use half AB sine theta. So area of triangle equals half AB sine theta, and half our A and B, this is root 29 and this is also root 29, and our theta is 2.38. So A times B, that's root 29 times root 29 sine 2.38, right? So it's half 29 times sine 2.38. That gives us 10.00 square units, right? And so to get the area of the segment, we're just adding these two, and that will give us 66.6 square units as the area of the larger segment, which is this. We divided it into a triangle and a sector, right?